Good day, my dear student friends. In this video session, let us learn how to derive the shape functions for one-dimensional cubic element. This is also one of the higher order element that already we have discussed in the previous video about the higher order elements. Now, one-dimensional cubic element, it is a four-noded line element. It is a four-noded line element. Node number 1 and 2 are the corner nodes, and 3 and 4 are the mid-side nodes. Okay, and now the natural coordinate values, first we will write. Natural coordinate values are at the left, that is -1, and to the right it is +1, and at the center the origin will be there at the center, but the nodes we have, the 3 and 4 are here. Then to the left, if we take the 3 parts, then you will get 1 by 3 here, 1 by 3 here. Hence the natural coordinate values for the one-dimensional cubic element, node number 1 zeta is -1, node number 2 zeta is +1, node number 3 it is -1 by 3, and node number 4 it is +1 by 3. Once you write these natural coordinate values, after that we will find the shape functions n1, n2, n3 and n4 by using Lagrangian form of shape functions. As we know that by using the formula zeta minus zeta I divided by zeta k minus zeta I. Okay, now the product of that ratio we will consider. First, to find n1, where k is equal to 1 and I is equal to 2, 3 and 4, that means 3 products we will get, product of the ratios. Okay, now first zeta minus zeta I divided by zeta k minus zeta I, that is zeta minus zeta 2 divided by zeta k. K is what? 1. Zeta 1 minus zeta 2. Next, I will consider I is equal to 3 now. Zeta minus zeta 3 divided by zeta 1 minus zeta 3 into, I will consider I is equal to 4 now. Zeta minus zeta 4 divided by zeta 1 minus zeta 4. Likewise, okay, we have got 3 products where the I ranges from 2, 3, 4. Okay, and k is equal to 1. That is in the denominator you can find k is equal to 1. That is I wrote zeta 1 only. Here it is going to only vary, that is 2, 3 and 4. Okay, once you write this formula, after that you substitute all the natural coordinate values, that is 1, 2, 3 and 4, that is zeta 1 is -1, zeta 2 is +1, zeta 3 -1 by 3, zeta 4 +1 by 3. All these values we know, you just substitute into this formula, you will get, if you substitute all these values, we will get n1 as, after the simplification, we will get n1 as 1 by 16, 1 divided by 16 into 1 minus zeta into 1 minus 9 zeta square, or in almost textbooks it is given that -9 by 16, or you can write this as -9 by 16 into zeta plus 1 by 3 into zeta minus 1 by 3. Okay, you can write, okay, zeta plus 1 by 3 into zeta minus 1 by 3. Okay, just here I have used a plus b into a minus b into zeta minus 1. Like that also you can write, both are correct. Okay, like this you can find. Now next page I will proceed how to find the n2 shape function, n2 value, where I is equal to, here for n2 1, 3 and 4, it varies from I is equal to 1, I is equal to 3 and I is equal to 4. Again you will get 3 products, 3 ratios, and k is equal to 2, that is at which the shape function has to be determined, n2 is equal to, here you can observe I wrote k is equal to 2, that is zeta k, that is zeta 2, zeta 2, zeta 2 here, but I is going to vary, that is zeta minus zeta I divided by zeta k minus zeta I, that is zeta minus zeta 1 divided by zeta 2 minus zeta 1. Next, third node, zeta minus zeta 3 divided by zeta 2 minus zeta 3. Fourth node, zeta minus zeta 4 divided by zeta 2 minus zeta 4. Once you substitute all these, okay, once you write the formula, okay, by using Lagrangian form of shape functions, next after that you substitute all the natural coordinate values, zeta 1 -1, zeta 2 that is +1, zeta 1 -1, zeta 3 -1 by 3, zeta 2 +1, zeta 3 -1 by 3, zeta 4 that is +1 by 3, and zeta 2 +1, like that. Okay, once you substitute all the natural coordinate values, once you simplify you will get n2 value 1 by 16 into 1 plus zeta into 9 zeta square minus 1, or this can also be written as 9 divided by 16 into zeta plus 1 by 3 into zeta minus 1 by 3 into bracket zeta plus 1. Okay, this is the n2 shape function. Next, after that shape function n3, here if you are finding the shape function n3 can be written as by using Lagrangian shape function L3 of zeta, where k is equal to 3, where k is equal to 3. Okay, and I should not be equal to k, I is equal to 1, 2 and 4. That means again 3 ratios you will get. Now I will write n3 is equal to zeta minus zeta 1 divided by zeta 3 minus zeta 1, zeta minus zeta 2 by zeta 3 minus zeta 2, zeta minus zeta 4 divided by zeta 3 minus zeta 4. Okay, where I is ranging from 1, 2, 4 and k is 3 only, zeta 3, zeta 3, zeta 3, like that. Zeta minus zeta I divided by zeta k minus zeta I. By using that formula we wrote n3 expression. After that you substitute all these natural coordinate values. We know zeta 1, zeta 2, zeta 3, zeta 4. After that, after simplification, we will get n3 as shape function at node 3, 27 divided by 16 into bracket zeta plus 1 into zeta minus 1 by 3 into zeta minus 1. Okay, now we'll move on to shape function n4. Node 4, at node 4, here n4 can be written as by using Lagrangian form of shape function L4 of zeta. Okay, that is at node 4 we need to determine the shape function, that is k is equal to 4, where I should not be equal to k, then I will be equal to node number 1, 2 and 3. Then here you can write zeta I is equal to 1, that is zeta 1, zeta 2, zeta 3, that is zeta minus zeta I numerator, and here denominator zeta k minus zeta I, zeta k is zeta 4, zeta 4, zeta 4 minus zeta I is zeta 1, zeta 2, zeta 3. Okay, like this. Once you write the formula, after that by using Lagrangian shape function, once you write the formula, after that you substitute all the natural coordinate values that we know, zeta 1, zeta 2, zeta 3, zeta 4, and simplify it. We will get n4 shape function at node 4, 27 divided by 16 zeta plus 1 into zeta plus 1 by 3 into 1 minus zeta. This is how we can derive the shape functions n1, n2, n3 and n4 by using Lagrangian form of shape functions. In the previous video also we have discussed that Lagrangian form of shape function formula for 1D quadratic element. You just go through that, my dear students. In this video I have covered the how to derive the shape function for 1D cubic element, to derive for n1, n2 and n3 and n4 shape functions. Variation of shape functions, it is like this. At node n1 is 1 at node 1 and it is 0, 2, 3, 4 and it is the variation is cubic. Okay, and the variation of the shape function is cubic for n1, n2 and n3, n4. For n1 it is 1 at node 1 and this curve represents n1 value, and the n2 is 1 at node 2 and it is 0 at other nodes, and it represents this curve represents, cubic curve represents n2 expression, and n3 is 1 at node 3 and it is 0 at 1, 2 and 4, and this cubic curve represents n3 expression, and at node 4 it is 1, at node n4 is 1, and at other nodes 1, 3 and 2 it is 0, and this cubic curve, it represents the n4 expression, that is 27 by 16 zeta plus 1 into zeta plus 1 by 3 into 1 minus zeta, like that. Okay, this is what the variation of the shape function is, cubic. Okay, now n1, n2, n3, n4, like this you derive the shape function. This is also one of the derivation which is been asked in one of the previous question papers. Okay, thank you my dear students, I hope you have understood. Thank you, take care, stay safe, stay healthy.